Hey, this is Ralph, and in this video we're going to use Excel in order to compare two scenarios. One scenario is a young person who starts investing right away for 10 years. The other person waits 10 years to start investing. All other characteristics, though, are pretty similar, and we want to see which young person is going to be better off in the long run. This is an activity that's part of an assignment that I use in a couple of classes, CIS 101, CIS 120. We're focused on using Excel in those classes in order to solve some problems. And here is our word problem scenario. So let's go ahead and do a little bit of setup. We have two people here, Kira and Kyle. So let's see. They are both the same age. So off to the side here, I'm just going to go ahead and write their age. And could just do a sequence function, but instead, I still will do a sequence function. Let's go ahead and do a sequence function. And the number of rows I want. Well, I don't know the number of rows because that would require me to do math in my head, but I can do a little bit of math here. So I could say something like, let's say they want to retire at 65, so we'll do 65 minus 22, their current age, but then I need to add 1 so that I get all the way down to 65. You'll see that work in just a second, comma. Now, the other parameters of the sequence function aren't really too essential. They're in brackets, they're optional, but how many columns do I want? I want 1 column. What do I want to start with? I want to start with 22, their current age, comma. What's the step that I want? I want 1. Now, if you're just leaving the defaults for these parameters, I could have just done an empty set of commas, just nothing in between, but that's pretty good and pretty clear. Now when I press enter, it's going to spill out, and this will take me all the way down to age 65 for these two young people. And do I want to center this? I think I will. I'm going to go ahead and center that column. Okay, now the other things we need to know are going to be for each individual. So we're going to have, let's see, I'll do a merge and center. This is going to be Kira over here, and this will be Kyle on this side. So with Kira, we're definitely going to want to know what is her annual investment. And we'll just go and say, we'll just put, actually, no, I'll do a space. We'll do it off to the side here. What's the investment going to be? And what's the balance going to be? And we'll do the same thing for Kyle. Investment and balance. And it looks like I can grab a little space, so I'm going to delete a few columns, and then I'm going to select these columns, make them a little bit wider, and I will format painter, select columns J and K. Oops, I can't do that because of the merge cells, so no worries. We'll do it that way. Okay, so now at least we can kind of see what's going on. I can make this column a little skinnier. Okay, so for Kira and Kyle. Now, the investment is going to be the same for both of them, $2,400. So for Kira, she's going to start right away. So I'm going to go ahead and put in the 2,400, and then I'm going to have the next cell equal to the prior cell, so that way I can easily change the number around. And let's see, that's 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that'll give us 10 values there. I'm just selecting those to confirm. Yeah, so she's going to invest for 10 years, and then she's going to stop. It's going to change to 0. And I will have that equal the previous cell. And I'm just going to fill that all the way down to age 65. And we want to see what the impact is going to be on her balance. Now, we can pretend that she's investing at the beginning of the year, or she's investing at the end of the year. And either way can work as long as you compare both people using the same basic technique. Let's pretend that she invests at the beginning of the year. So it's January 1st of a particular year, and she's going to invest $2,400 into a index fund or something like that. Yeah, I know you can't invest on January 1st, but we'll pretend that she can. Now, if she invests $2,400 at the beginning of the year, at the end of the year, she should have more than $2,400. It would be that $2,400 investment plus any growth she got on that money. So we do need to keep track of the return, and we want to make it the same for both folks. This is a number that I might want to change from time to time, so I'm going to stick this number right up here, and we'll just start off with something like 10%. That's not an unreasonable number for a couple of 22-year-olds. They have a long time horizon, so calculating an average 10% or even 11% wouldn't be out of line, I don't think. So let's go to the first balance here for her investment. So she invests $2,400 at the beginning of the year. How much does she have at the end of the year? That's going to simply be equal to her investment times 1 plus whatever her interest rate is. Of course, 1 plus 10% is 1.10. And which is 1.1. So basically taking her investment, multiplying it by 1.1 in order to find out that, okay, great. At the end of the year, she's going to have 2,640. Perfect. You know what? I'm going to take a moment and I'm going to go ahead and select all of these cells. And I will just format them as currency, but I'm going to get rid of the decimal places. Okay, so now, all right, that makes sense. Now the tricky one happens in the second year. But the good news is after we take care of the second investment year, all the rest we can just copy and paste. Okay, now the second year is a little bit different, right? The second year has to include the money she had at the end of the prior year. So it's December 31st, she has $2,640 in her account, and then January 1st comes around again, and she adds another $2,400 to that. So basically, we're going to take the old money plus the new money. Excellent. However, the whole year goes through, the second year, and she's going to get growth on the combination of this money. She's going to get growth on the 2,640 and she's going to get growth on the 2,400. So we're going to add in old money plus new money multiplied by interest rate. And just to keep these a little bit more organized, to make sure things happen in the right sequence, I'm going to wrap those in parentheses too. So check out this particular formula. It's a little bit longer, more complicated, right? So we're taking the old money and the new money, adding them together, and what does that get us? That gets us 2, 4, a little over $5,000, right? So about 5,040. So that's $5,000 right there. And then we have to figure out what is 10% of that 540. So we can write it this way. Now, yes, could have done the multiply by the 1.1. That's actually not a bad way to go. So just to kind of simplify it, make it more like that first formula, let's give that a shot. So I'm going to multiply this and we'll use our parentheses again by 1 plus the interest rate. And that should give us the exact same result. So we know we've got about 5,040 added to that. 10% of 5,000 is 500. So I would expect a number closer to 5,540. It'd actually be just a little bit above that, I imagine. 5,544. Perfect. So now we can see that, okay, the first calculation was her investment plus or times 1 plus the interest rate. The second one is going to be the combination of the old money and the new money times 1 plus the interest rate. Now that we've got that taken care of, we can just double click that fill handle and autofill it all the way down. Now, as she adds money to her account, it keeps on growing and growing and growing. But the great thing is even when she stops adding money to the account, it still continues to grow by 10% per year. So even though at age 32 she's not investing anymore, that money is still growing by $4,000, $5,000, $6,000, depending on the situation. And as we can see, the money climbs and climbs and climbs. And sure enough, by age 65, she has $1 million, even though she invested a relatively small amount. How much did she invest? Let's just do a quick sum down here. And actually, I'll just do Alt equals. That'll give me a quick sum of the entire column. Let's just confirm. Yep, it's going to the right amount there. And I'll press my enter key. She only invested $24,000 in order to get to that $1 million balance at the end of her retirement plan. Okay, now to figure out Kyle's situation, very, very easy because we're using the exact same formula. In fact, we can go ahead and select all of this data. I'm going to put my cursor on the border of the selected range. I'm going to hold down my control key and then click and drag over to Kyle's side, let go of the mouse, let go of the control key, and we see we get identical results. However, he's got a different plan. he's going to invest 0 from the start, and then he's going to start investing $2,400 after that 10-year wait. Now, of course, he can never really catch up because it takes him, 10 years just to get where Kira was 10 years ago. And so if we look all the way down at the bottom here, we can see that he's had to invest over $81,000 compared to Kira's $24,000, and he only gets to $650,000 in his retirement account versus her $1 million. So we use this activity for a couple reasons. Obviously, the most obvious is we get to use Excel in order to determine the better of two scenarios based on these two folks here. The other benefit is, hopefully, this is what I want for my students, is hopefully it maybe motivates them and encourages them to think about, hey, maybe I should start investing now rather than waiting till later. Obviously, I'm a big fan, get out of debt first before you start investing, but as quickly as possible and as efficiently as possible, get out of debt and start investing sooner while you're young as opposed to waiting, because even starting at 32, which is still quite young, you can't quite get there. Now, what does Kyle need to get to over $1 million? You know what? I think I can use a goal seek for this. I'm going to start up my goal seek utility, and I want to set his final balance to the value of $1,080,000. So I'm just typing that in by changing his first investment of $2,400. I'm going to click OK. I'm going to click OK. Oh, wow, it's a nice even number. I'm a little surprised. No, but that works. So he needs to invest $4,000 a year just to get to Kira's level. And that requires a total investment on his part of $135,000, $136,000 almost, compared to her little measly $24,000 investment. So once again, the power of investing early. So this is the solution to our word problem. And if you made it this far in the video, thank you very much, and I'll talk to you later.